All right, time is up. Time is up. Happy, what is it, Tuesday? How do you guys like this new schedule? How do you guys like this new schedule? I like that we have an extra long lunch. That I see only one advisory. It was kind of, I wish they would have had, I wish from the beginning I would have had just one advisory, because I'd have to have an advisory and then lunch and then the other advisory. It just didn't make sense to have them cut up into two pieces. So I kind of like that. Yeah, we all got to get used to it too. And then those of you returning tomorrow, that gets a little more confusing, but once you get, I think the rest of this week you'll get the hang of it. All right, so let's go over this. All right. So what do we do first? Well, we look here. We need to get the radical by itself, but oh yeah, you guys saw your teachers in their classrooms. Yeah. I'm not. I'm kind of, it would have been nice to be in my classroom, right? Just to see people and see students. It would have been nice, just some little normality, but still, I'm not, I got to keep my little boy safe. And of course myself and the rest of my family, but him especially. But anyway, I don't envy them though, because school ends at 2:20, and they have to stay there for office hours and stuff till 3:30, and I can still do my office hours here at my desk. So they're kind of stuck at school. So I kind of felt bad. And then the parking situation was kind of bad. That's funny. So yeah, one of the teachers in the 700s texted me. He's like, "Oh, I had to park all the way in the basketball courts." I'm like, "Oh, that sucks." I'm like, "I had to park in my driveway today." So that's kind of nice. Yeah, that's crazy. That's crazy. So I think I made the right choice. And hopefully August everything will be normal. We can all see each other again. Except for you seniors, I'm sorry. All right, so what do we do here? There is no way. There's two different radicals, but they both do have the same index. It's shady. You think that's shady? I'm just maybe rubbing it in a little bit too much. He's my friend, so I could tell him that. All right, so what do we do here? I have two different radicals, but they are the same index. I guess a little bit. Yeah, that was kind of mean. You're right. That was kind of mean. I said sorry. I said JK, sorry, LOL. Just so you know I was joking. All right, so what do I do here? Guys? I need to get rid of that radical. Now I can't get them both to the same side because they're different radicals. They have different insides, so I can't really combine these. So what do I do to get rid of this radical? Knowing that they both have the same index, which is good. I can turn them into fractions, fractional exponents. I could, but that's not what we do, right? Remember what are the steps? We're trying to get rid of the radicals, right? So you could change them to, what number? Wait, where were we? What number were we doing? Here we go. There it is. Sorry, I lost it for a second. Yes, raise both sides to the third power. We can raise both sides to the third power. Right? So raise everything to the third power. Now be careful with the right side. So the left side, this is easy. Cancel, cancel. We're left with 14 minus 10n equals, okay, what are we raising to the third power? We're raising this to the third power and this to the third power. So what's negative 2 to the third power? Right? We could have changed them to fractional exponents, but we still would have had to raise it to the third power. So yeah, that would be negative 8 times what? Well, what's this to the third power? What's this second one to the third power? Well, we just cancel. Right? Cancel, cancel, and it's just an n. And so now we have 14 minus 10n equals negative 8n. And so what I'm going to do is I'm just going to add 10n to both sides. And I'll get 14 equals 2n, divide by 2, n equals 7. We're done, right? N equals 7, we're done. Right? We're done? Hello? Can I get a yes or a no or a maybe or something? Hello? Anyone there?
Bueller, Bueller, Bueller.
Okay, someone said yes. Someone said yes. No. What do we have to do? What do we have to do? Remember that long word? We need to check to see if this answer is extraneous. Right? We need to see if it actually works. So we're going to plug it back in and see if it works. So let's see. Let's rewrite the equation. Cube root of 14 minus 10 times n, which is 7, equals negative 2 times the cube root of n, which is 7. So let's see if it's true. Okay, so let's check this and then I'll recap the whole problem. So let's see. Now we have the cube root of 14 minus 70 equals negative 2 times the cube root of 7. Well, what's 14 minus 70? What's 14 minus 70? Negative 56. Oops. Negative 56. Does that equal negative 2 cube root of 7? Well, negative 56, it's okay to have a negative in this radical because that's an odd index, so that's okay. But let's see, negative 56. Well, if I think about that, isn't negative 56 the same thing as negative 8 times 7? Right? I'm trying to figure out a way, and yeah, 56 can also be 28 times 2. It can be a whole bunch of other things. It could be 14 times 4. But the reason I chose 8 and 7 is because I want to try to match this with this side. And so I'm trying to get a 7 in here, right? So that's why I know 56 is 7. There's the 7 times negative 8. And then if I separate these, I give this one its own radical, and then this one its own radical. Well, the cube root of negative 8 is negative 2. And then I have cube root of 7, and that matches. And so, yes, that's a solution. So, yes, that is your solution. It's not extraneous. It works. Okay. And so let me recap. Somebody asked me to recap. So to recap, we are just looking at this equation, and we're trying to figure out how to get rid of the radical. Well, I can't combine anything. I can't get rid of anything. This negative 2 is here. It kind of bothers me that this negative 2 is here, but I do have a radical by itself, and I do have a radical here by itself, and nothing's being added or subtracted to this. So that's why we just rose this to the third power and rose this. Remember, you got to do the entire side. You can't just do a piece of it. So I put this entire side to the third power and this entire side to the third power because a third power and a third index, a third root, cancel out. So that's why I left with the insides. And then here, third power, this negative 2 was on the outside, so negative 2 to the third power is negative 8. And then this to the third power is just cancel, cancel. That's why it's just an n. And so now I have this equation. It's just a basic middle school equation where you just get the n's by itself, add 10n to both sides, divide by 2, n equals 7. And then once you get an answer, remember with radicals, sometimes radicals behave differently, so we need to plug it in to make sure that it works. Okay, that it's not extraneous. Because if you plug it in and it doesn't work, that's an extraneous solution. That means it's not a real solution. It doesn't work. Okay, but this one does work. We plugged it in and it did work. Okay, so before we move on to trigonometry, I know that sounds difficult, but it's not. And hopefully you had some experience with trigonometry last year with your geometry class. I know I was going over it when the pandemic hit in my geometry class last year. And so you guys got it. Those of you that had me for your geometry last year, you had your taste of geometry, but it was through videos I made, and it was kind of a mess when we started the pandemic last year. It wasn't as organized as it is this year. Like we didn't have a set time to meet or whatever. I just put up videos and you did work, and it was kind of a mess. But before we go to Trig, are there any questions on anything? Remember the 2 homeworks from last week. There are 2 homeworks from last week. You have where is it? This homework, the rational exponents homework, right? Yeah, this homework's only 1 page, and then you have this homework, solving radical equations homework. Okay. Are there any questions on anything before we move on to the new stuff? Nice. You were able to get a PS5? Nice. Yes. What 2 problems would you like to do? Well, I'm excited for your PS5. I'm a PlayStation guy. I'm a Xbox guy, but hey, PlayStation's good. Yes. Which 2 problems would you like to do? On the other homework? I think you said the other homework, right? On this homework? On the rational exponents homework, or the solving radical equations homework? This one? Okay. So you said number 5 and the last one. So here's number 5. So remember, if you forget, like, what do I do here? If you're confused, then you look back here at your notes and you go all the way up here. Remember I told you to highlight it? These are all the steps you need to do. So step 1, isolate the radical. Get the radical by itself if you can, or get it by itself on each side if you can. So that way you can just raise it to that power. Try not to have anything adding or subtracting, because that makes things more difficult. And then we raise each side of the equation to the power of the index. So that way it cancels it out. Then we solve the equation, and then we check for extraneous. So number 5, I have a plus -7 here. And remember, I don't want any pluses, because if I rose this to the 3rd power, that's a binomial, this times this, and then it's a big mess. So we don't want that. So what we do is we add 7 to both sides. And this is gone, so we get 16p. Now, since we're dealing with radicals, actually, let's do this. Since we're dealing with radicals, we should write this as 16p plus 8, 3rd root, right? 3rd root equals 6. Okay. Could you have left it like this? Sure. But since we're solving radical equations, change this to a radical. And now we see the radical is by itself. So this is a 3rd index. So I'm going to raise this to the 3rd power. I'm going to raise this to the 3rd power. Cancel, cancel. And we get 16p plus 8 equals 6 times 6 times 6. Which is what? 6 to the 3rd power. 6 times 6 times 6. Mister, why don't you do it? Yes, I do know what it is, but I passed this class already. There you go, 216. And so now we have a regular equation. So we subtract 8, 16p equals 216 minus 8, which is 208. Divided by 16, divided by 16. P equals, what's 208 divided by 16? Anybody? 208 divided by 16 is 13. Very good. So there's our answer, but we need to do step 4 because not all answers work. We need to actually plug it in right there. So it's -7. Actually, let's do purple. -7 plus, I'm going to do radical. 3rd root of 16 times p, which p is 13, plus 8 equals -1. Ah, that's your soccer number. Your soccer number is -7. That's weird. I didn't know they let you put negative numbers on. They should allow negative numbers. They should allow negative numbers for uniforms. I want to lobby for that. Negative numbers. All right, so I did, this is a third power, but I just made it a root just to make our lives easier. So now we have -7 plus the cube root of 16 times 13. It's 208 plus 8 equals -1. And so we have -7 plus the cube root of 216 equals -1. Ooh, we know this. The cube root of 216 is, we just did this, right? We just did this over here. If you notice, a lot of these steps we did over here are just the steps we're doing here, right? What's 6 cubed? 216. So the cube root of 216 is 6. 6 equals -1. And is that true? Yes, that is true. So this is a solution that works. Yay. Now, where were you stuck? Which part of this? Because that's the interesting part. That's when students ask questions. I'm always wanting to know what their point of confusion is. Like, where were they stuck? Like when I taught Avid years ago, we'd have tutorials twice a week, and you'd have to. The whole key was you have to bring questions that you have from other classes, and then when you're in your group, as your group is helping you solve it, or as you're going through it, you have to verbalize your point of confusion. Right? Oh, the fraction looks scary. Yeah, just change it to a radical because we're solving to radical equations, right? Just change it to a radical, and then it becomes a radical equation. So the fraction looks scary. Yeah, fraction just means a radical. That's all that means. Remember, a fraction just means a radical, and the denominator is your index, and the top number is the exponent that goes in there. You're still confused, or you good now? All right. And now the last one. What's your point of confusion here? Oh, this one's tough. This is the one where I said, okay, so this is where it gets a little messy, right? This 7, I can't get rid of it because if I subtract 7 here and subtract 7 here, it's still going to be over here -7. And I can't get these radicals together, so what do I do? So here's what you do. This is a square root, right? So that means if I square both sides, I got to square the entire side. So this side's easy. The square root and the square cancel, so I'm left with q minus 21 equals, this side is not as easy, but it's not that bad because I'm squaring two things being added together. And if I square two things being added together, that's a binomial. So I can do this. I can just multiply using a Punnett square. I'm multiplying square root of q plus 7, square root of q plus 7. And so let's see what that gives us. So this is going to equal something ugly, but it's okay. So let's see what we get. So we get square root of q times square root of q, which is q, right? Because square root of q times square root of q would become square root of q squared, right? It would become square root of q times the square root of q would be the square root of q squared, which cancel would just be q. And then this is 7 square root of q. This is 7 square root of q. And this is 49. So put these together, we get q plus 14 square root of q plus 49. Yeah? And so we get q plus 14 square root of q plus 49. Yeah? So that's the tough part. The tough part is that plus 7 makes this messy because if I subtract it, it would just go over here. So just leave it here with the less complicated q, with the less complicated radical. You see how this radical is a little more complicated? I would just leave it here with the less complicated radical because when I square this, it just becomes square root of q plus 7 times square root of q plus 7, and then I get this. Okay, and so now once I do that, it looks kind of like a mess, like, uh-oh, I can't do this, mister. Yes, you can, because look, if I subtract q from here and I subtract q from here, guess what happens? The q's are gone. And so now I have -21 equals 14 radical q plus 49. And now it's just a regular old equation where I subtract 49 on each side. And I get negative, what is this? Negative 70 equals 14 square root of q Divide by 14, divide by 14. Square root of q equals what? What's negative 70 divided by 14? Negative 5. And so if I square both sides, I cancel, I get q equals 25. Okay? And now we got to go back to the original equation, and plug it in. So is q equal 25 extraneous, right? So then we just plug it in. So square root of 25 minus 21, does that equal the square root of 25 plus 7? So this becomes square root of 25 minus, so that's square root of 4. Does that equal 5 plus 7? So that's 2. Does that equal 5 plus 7? That is not true. So this is extraneous. So there is no solution. Extraneous just means it's a solution that doesn't work. So after all of this work, there's no solution. The answer we get after solving it doesn't work. The way this would work is if we had the negative, because remember, when we take the square root of 25, yes, there are two answers, positive 5 and negative 5, but when we're just taking the square root of 25 in an equation, we always take the principal root, whatever sign is in front of it. Since there's no sign in front of it, we just take the positive root, which is 5. If I had a negative in front of here, it would have taken the negative root, and I would have had negative 5, and that would have been true. Negative 5 plus 7 would have given me 2. But this is taking the principal root, the positive root. Okay, so let me give a minute to copy this one, then I'll go back to number 5. So you can copy that one, and then we'll start our new stuff. We're going to have to, it's already 1:05. Okay, we have to start the new stuff and then finish it up tomorrow. So that's okay. The Xbox Series fridge. I like my fridge. Yeah, it's already 1 o'clock. Yes, I am recording this. So again, if you need to get your homework in this week, go ahead. Don't fall too far behind though, guys, because you are going to have 2 more homework assignments this week. But here's the good news. I have good news for you. The next 2 weeks, we are having testing. I do not plan to give homework during testing. Okay? And you guys just are still going through testing with English right now, right? This is your second week. So that's what you're going to be doing with math next week. So you do have 2 more homework assignments this week. You had 2 last week. All right, I'm going to go to number 5 now because someone wanted me to go back to number 5 and copy so they can finish copying. There's number 5. If you got these already and you're not copying these down, go to Schoology and get the new notes. It's in week 15. Oh, and by the way, yes, I do turn in 15-week grades this week. It's just a progress report. It's not a final grade. You'll find your final grade is in 6 weeks. There's 6 more weeks of school, guys. Crazy. So yeah, so I do turn in progress report grades this Friday. So if you've copied all this already, go to Schoology and get the new notes. It's called Intro to Trig Notes. I'll explain SOHCAHTOA. I'll explain sine, cosine, tangent. I'll explain how to find that on your calculator. All that good stuff. Friday is the last day to turn in grades for this progress report. Remember, it's just a progress report. If your parents get that progress report, you can always show them your current Schoology grade and say, look, that's just a progress report. Here's Schoology. Here's my current grade. This one's more up to date. Because it takes like a week for you to get that report card in the mail. So if you don't like the grade the report card is in, but the grade that the report card has, you can always show your parents Schoology and say, look, this is more up to date. Hopefully it's better or the same. Right. So, so this Friday I turn in their 15-week grades. It's a progress report. It doesn't stay on any record or anything. It's just your last progress report before the final grade in 6 weeks. All right, so again, go to Schoology. What happened? Go to Schoology, sign in. You're welcome. Oh, did you guys get this? If you're going back tomorrow. There you go. So go to our course, period 13. Go to week 15. And you'll see we have 3 things there. We have the Intro to Trig notes. I have the Intro to Trig solutions. So I have all the notes worked out already. So you know how when we take notes, we don't always go over all the problems. There's just too many. So some of you that want to try some of them and look and see if you got it right, the solutions are there. And then there's the homework. It says it's due Thursday. But again, if you want to turn it in Friday, I will not be mad at you. And again, we have that support Monday. So you still have time. You have time if you're behind on the other 2 homeworks. Okay, so then go ahead and open your Intro to Trig notes. I know it says a due date. Do not turn in notes. You do not turn in notes. I'm talking. You can't hear me? Hello, can you hear me? All right, hold on. You can hear me. Oh, okay. Okay, so then get your trig notes. Remember, there's no due date. There's no due date. I mean, it says it's a due date, but this is not an assignment you turn in. Okay. So I'll let you get that. Open it up. And remember, I only do this as an assignment so you can open up with Cami. So here we go. Oh, I don't think I have it open. Okay, so I'll give you a second to open that while I go get it. And it should look like this. Okay. All right, so we have about 8 minutes left of class, so we're going to start talking about this. Does anyone know what trig? You guys have heard the word trigonometry a lot. Oh, there you go. Okay, good. Does anyone know what trigonometry means? The definition of trigonometry? Anybody? See, a lot of you go through life or go through school life, even sometimes life, just hearing things and never questioning, what does that really mean? Right? It happens. I remember I would do the same thing when I was your age. There was so many things that later on I would hear definitions of things and I'm like, oh my God, that makes so much sense. It would be like, I'd be like, oh, okay. Ooh, here we go. Oh, someone put in, I like to see. Trigonometry is a branch of mathematics that studies relationships between the side lengths and angles of triangles. I believe you said that right from your head, right? You didn't get that person in the chat that said that? No. I'm not offended. And it's okay if you copy and paste it, because that's what we do, right? If we don't know something, we go to Google. Google is our friend. It's okay to ask Google. So basically, if we want just and person in the chat, that's an excellent job. Okay, I'm going to write that down. This is the official one. So is the branch of mathematics that studies relationships between side lengths and angles of triangles. That is the official nerdy definition, and I like it. That's nerd approved. Nerd approved. Okay. I was just basically going to tell you it's the study of triangle measurements, which just is a simplified way of saying this. But yeah, the one in the purple is the official nerdy, nerd approved definition. Branch of mathematics that studies relationships between side lengths and angles of triangles, or the study of triangle measurements. Okay. Now we start with right triangles, right? With trigonometry, we always start with right triangles. Okay. So do you guys know what a right triangle is? Okay, I kid you not, I drew a triangle like this, but I drew it like this one year. And then I had a student, I kid you not, I know everyone says, "No, you're capping, mister." No, no cap. Student said, "Mister, is this a left triangle?" Bruh. I said, What? He's like, "Yeah, mister, is that a left triangle?" I'm like, "Why do you say that?" He's like, "Because my whole life, right triangles look like this. And all my teachers drew them like this, where this faced to the right. And so now you're doing it this way. So that must be a left triangle." Bruh. I said, "Why do you think we call it?" See, this is one of those moments where you hear words, but you don't really understand what it's saying or the meaning of it, like the definition of it. So you just say, "Oh, okay, that's right triangle." Whatever right means to me, right just means my right hand. And so it makes sense. Well, the reason we call it a right triangle is not because of the direction it's facing. It's because of the angle it has, right? A right triangle, because it has a right angle, right? So one thing you should remember about right triangles, and I'm not going to review it, but you should know that this is the right angle, which is 90 degrees. And these are the acute angles, because they both have to be less than 90 degrees, right? Because when you add all three angles should equal 180 degrees. And if this is 90 already, this can't be 90 because that's 180 already. They can't be over 190 because then it'll be over 180. Remember, this plus this plus this has to equal 180 in any triangle. So we know these little angles right here are called the acute angles, and those are the ones we're going to focus on in this introduction. And then lastly, you should know leg squared plus leg squared equals hypotenuse squared. And what do I mean by that? I mean the two sides that form the right angle, those are your legs. And this side, this long side of the triangle, is called your hypotenuse. Okay? And so leg squared. But mister, yeah, I remember my teacher taught me a squared plus b squared equals c squared. Yeah, I don't like that. I don't like that. Because what the heck is a, b, and c? Right? And yes, a, b, and c are labeled here, but what if I put a right here, b right here, and c right there? Then it just throws everything out of whack. So you need to know it's leg squared plus leg squared equals hypotenuse squared. Just get the two legs, square them, put them together, and then equal it to the hypotenuse squared. Because a, b, and c doesn't tell you exactly what parts of the triangle you're talking about. Leg squared plus leg squared equals hypotenuse squared is a way more accurate way to talk about the Pythagorean theorem. Right? So you should know that. That's something you should know. Okay? So we're going to stop talking right now, but I'm just going to give you a clue as to what sine, cosine, and tangent are. Okay? All those things are ratios. And when I talk about ratio, you're just comparing two things. So I'm just making a fraction of two things. So when I say sine of something or cosine or tangent, I'm just saying I want to make a ratio. That's it. And we're going to use those ratios to help us find things like side lengths and angle measures. Okay? Today and tomorrow, we're talking about introduction and talking about finding side lengths. And then Thursday and Friday, we're going to use the same trig to find angle measures. And you're going to need your handy dandy calculator to do that. You will not be able to do it in your head. Okay? So we will continue this discussion tomorrow. We will continue this we will continue this discussion. I was going to say conversation and discussion at the same time. We will continue this discussion tomorrow. Have a great day. I know this is a little weird, but this is the first day of our new schedule. So have a great rest of your Tuesday, and I will see you all tomorrow.